Hello, my name is Kylee Kublin, and for my quarter one experiment, I have decided to measure mass versus speed. So, you're probably wondering, Kylee, what exactly will be tested in this experiment? I will be testing the independent variable x as mass measured in grams versus the dependent variable speed measured in seconds for y. I will be controlling the water temperature of my experiment, the distance, person dropping the item, person setting the timer, and the container of my experiment, which I will show a picture in the next slide. So, what will I be using to have this experiment be proven? So, I have created a hypothesis that if the mass of an object increases, then the sinking time of that object will also increase. If the mass of an object decreases, then the sinking time of that object will decrease. This will create a direct relationship because if mass increases, so will the sinking time, and vice versa if mass decreases. The reason behind this is because the heavier the object, the more surface area is required to be covered by water, therefore creating a longer sinking time. If the object's mass is lighter, then there will be less surface area for the water to cover and therefore taking less time to sink. In my image, you can see that the water container has a designated sinking spot, is being measured by a ruler for the distance, and I'm using paper clips as my object to sink. The water temperature is about room temperature, just slightly colder. Now for my experimental procedure. First, the student, or me, gathered all the materials including a container, water, object to sink, ruler to measure distance, and timer. My objects to sink was a paperclip, which I would therefore increase the mass by creating chains of them, by increasing them by 1. Secondly, the student will be weighing the objects on the scales and recording the mass on the table. The student will make sure to record which object corresponds to which box. For me, I was able to record the objects and by weighing them on a scale provided by my science teacher, and in later slides I will show you which table corresponds to which. Then the student will fill the container with water, making sure the water is at a constant temperature. Once filled, the student will place a ruler inside the container and make sure the water is at the correct distance. This distance will remain constant. As I showed you in the picture, I do have a ruler, and the temperature was about slightly colder than room temperature. The student will then have to place the water and keep track of the speed of the object. They will also have to make sure to have all materials with them. Alongside my container, I kept all my materials in a very nice line, and I made sure to track the speed, resetting the timer for every single trial. Then the student will proceed with placing the objects into the water and timing the sinking rate of the objects. This will be recorded in the data table. In later slides, I will show you this data table, and in the next ones, I will show you each individual trial. Once finished with all the trials, the student will clean up and continue with other parts of the experiment. These other parts I will show you now, and yes, I did clean up. So now for my first trial. Here is my first video. So as you can see, that was the single paper clip, which weighed 0.40 grams, and it had a sinking time of 2.16 seconds. So you're probably wondering, okay, what factors or things might have influenced this? So I actually repeated this trial twice. This is my second time, I believe, to get the most accurate reading. I only did this one and I think a couple others twice because I wanted to make sure this experiment worked. So now the object actually took me quite or proved to be taking quite a while to reach the bottom. I was actually quite surprised by this because I thought it was going to be light, so therefore it was going to be really quick. But no, it actually took quite longer than I predicted. I also noticed the water moved quite a bit afterwards, which is interesting because it has a smaller surface area than the other trials, which you will see. And I thought it was interesting how the water keeps moving from this. Okay. Okay. That is my second trial, which I completed right after my first one. The weight of this object was 0.8 grams, and the sinking time was 1.40 seconds. So, like I said before, this trial was only completed once, and I also noticed that the water took quite a while to settle down after this. I figured that this might have been because the surface area was increasing, so therefore it was creating more ripples in the water. And that's something quite interesting to me because I actually thought that there wouldn't be as many ripples and the water would just be kind of constant. And because of these ripples, the surface area is increasing as well as the mass. Okay, so this is my third trial. The weight of the object is 1.2 grams, and the sinking time is 1.28 seconds. This trial was completed once, and now you can see the weight is triple the amount of the first trial, which was 0.4 grams. Now we can see the seconds are really starting to decrease. As I mentioned in my hypothesis, I actually thought the seconds were going to increase as well as the mass. And here we'll continue to see this negative trend throughout my data. I'm sorry, this doesn't seem to be working. Oh, I'm sorry, this is loading quite a while. There we go. Okay. So now the weight of this object is 1.5 grams and the sinking time is 1.25 seconds. So this trial was completed once, and I'm getting better at aiming the object towards the center, which is quite nice for me because I've had to pick them all up. And I've noticed the surface area is getting greater, but the sinking time is decreasing. The last sinking time was 1.28 seconds in the third trial, but now it's 1.25 in the fourth. So the distance between each time keeps decreasing from this to like that. And maybe we'll see this trial continue in the fifth. Okay. So now the weight of this object is 1.9 grams, and the sinking time is 1.22 seconds. This trial is created once, but the distance between the seconds is decreasing, and the surface area, it's slowing the object slightly, but it's not as affecting the object as I thought it was. And this is really interesting because it seems to be disproving my hypothesis. Now, here is the sixth trial. Okay, the weight of this object is 2.3 grams. The sinking time is 1.07 seconds. So this trial is completed once, and this is officially the start of the second half of the trials. The surface area continues to increase the mass, but now the sinking time, it's not really differing from the other ones. This seems to continue the trend of the negative slope. Yeah. Okay, the weight of this object for the seventh trial is 2.7 grams, and it has a sinking time of 0.99 seconds. I've only completed this trial one time, and this trial took less than 1 second by 0.01. I noticed that it's being quite harder to keep track of the time when I am timing this. However, it keeps decreasing, so I've done my best to continue to stop the timer at the correct spot. Okay, the weight of the eighth trial for this object is 3.1 grams, and the sinking time is 0.94 seconds. This trial was completed once, and this is the least amount of seconds we will see in this whole data table. And it's the lowest amount of time reached. It's quite interesting that it would plateau, essentially, the data for the seconds and speed at this trial, which kind of reveals to us that the sinking time, or at least the time that it takes an object to get through water, is really most affected around 3.1 grams. Sorry. Okay. There we go. Sorry. Okay, the weight of the ninth trial is 3.4 grams. It has a sinking time of 1.12 seconds. Some factors and things I noticed was that this trial was actually repeated twice because I wasn't quite sure first about the sinking time because it increased from 0.94 at my eighth trial to now 1.12 seconds. This is the point where my trial starts to create a curve in my graph. And it's actually one of my outliners because I didn't predict this in my data. So we can assume that around 3.1 grams, the sinking time is at the most fast point. Okay, that is my 10th and final trial. The weight in the largest object I have measured is 3.8 grams. The sinking time is 1.32 seconds. Some things I noticed, this trial was also repeated twice because, again, I wasn't quite sure about the seconds. This item took quite a while to reach the bottom, and it's my biggest outlier as it has not followed my predicted trend. It's quite interesting because I think this is where surface area starts to truly affect the objects that I'm testing. And it really just shows me that surface area also affects this, unlike it had affected my fourth or third trial. Okay, now here's my completed data table, which I had listed all of my values of these numbers previously in my um, individual trials. And you can see that at about the second to last trial, the seconds start to increase instead of a decrease, which is really interesting compared to some of the others. And you can see that the grams of the objects about increase by zero point 0.4 roughly. So now here is my first graph of my data. I chose a linear fit because that's what I originally had done, and my formula will be y equals mx plus b. You can see the two top are outliers, even though I would argue that the second to last point is also an outlier due to it not following my trend, but everything is slightly below this best fit line. But I think that mostly it's affected by these top two outliers, which really do change my data. And here's another one with a different line. This is a curved line. And I wanted to show this because it really shows that my data is more in a curve than anything. We see that the data kind of curves, has like an oscillation or like slight curve upwards and then a curve down, back up. It's almost like a hill, which is quite interesting. And this could be in discrepancies that I personally have, but again, it's kind of just meant to show the fact that it is a curve. Okay. Now, my Logger Pro calculations. This was given to me based on the computer. So I found that y equals negative 0.1969 seconds over grams times x plus 1.690 grams, which is my y-intercept. My personal calculations found that my y-intercept is negative 1.9 seconds over grams times x, and my y-intercept is 2.92 grams. In order to find an estimate or an example of this calculation, I decided to use to insert 4 grams as my x to find a rough estimate. For the Logger Pro graph, I found that if I inserted 4 grams for my x, I would get 0.9024 seconds. For my personal calculations, I got negative 4.68 seconds. So I've decided that the Logger Pro calculation or sample formula is the closest to my data, and that's the one I will be using. So now it's time for my relationship. There is a negative, nonlinear, and moderate correlation creating an inverse relationship between mass of an object and the sinking time. When the mass of the object would increase, I found that most likely the sinking time of the object would decrease. As the mass of the object would decrease, it was most commonly found in my data that the sinking time would increase. This is an indirect or inversely proportional relationship. For example, I found that the mass rises from 0.40 grams to 1.20 grams, the sinking time of the object would decrease from 2.16 seconds to 1.28 seconds. When the mass decreases from 3.10 grams to 1.90 grams, the sinking time increases from 0.94 to 1.22 seconds. Within my data, I also found some outliers which I would like to acknowledge as the point 3.0 grams, 1.2 seconds, and the other point of 3.8 grams and 1.32 seconds. These points caused my data to create a curve which was not predicted in my hypothesis. So, overall, I would like to formally reject my hypothesis and therefore state that when the mass of an object increases, the sinking rate most of the time of the object will decrease. This creates an indirect relationship as well as a curve due to a few previous outliers. While the surface area did affect the outliers mentioned as their sinking time increases, it did not affect all of my data as mentioned in my hypothesis, making it an uncommon variable that would affect it. My final equation, which I found for this experiment, is y equals negative 0.1969 seconds over grams x plus 1.690 grams, because I have found that the most likely trend to follow, which is mentioned prior to this. This equation reveals that there is only a small m variable or slope, while the b or y intercept is greater. Again, I must mention that my graph was found to have a curve which changes the y equals mx plus b formula, but my line of best fit is meant to show the predicted trend if all my points followed a linear trend. When I did my experiment, I was able to control the temperature of the water, distance, which was 12 inches, person dropping the object, person recording the time, and container, which was quite easy. However, I found it hard to deal with collecting the item after each trial as well as trying to record each trial. If I were to redo this experiment in any way concerning the procedure, I would have added a small net like the ones used for fish tanks to help me collect the objects after each trial. Instead of having 10 different objects and weighing different sizes, I would use the same one but add onto it like a chain of paper clips. Besides that, I think I would have kept the same main ideas, which was seeing the effects of mass on sinking time. So when I was creating this experiment, I wanted to do something that involved the sinking rate of an object since I love to go on boats and participate in water activities. I decided that I wanted to see how the mass of boats affect their sinking rate. According to Scientific America, if too much weight is added, the ship's density becomes greater than that of water and it sinks. Excess cargo would need to be thrown overboard in a hurry, or it's time to abandon ship. I thought this was quite interesting since many cargo ships have to carry a lot of material across the ocean without sinking. So I think that it must require a lot of mathematical calculations in order to prevent these ships from reaching this density point. Additionally, in the article by Britannica, if the object weighs more than the water it displaces, the buoyancy force acting on it will be less than gravity, and it will sink. This all affects the boats and the objects which I have tested, proving that the weight of the object is going to affect if it's going to sink or how fast it will sink into the water. Overall, I have found that if mass increases, then most likely the sinking rate of the object will decrease. So, here are my outside sources, and I would like to thank you for watching and listening to my presentation on mass versus speed.